Hello everyone. All right, welcome back. And today I'm going to show you how you can evaluate this difficult definite integral by means of the Landen's transformation. It's called the Landen's transformation, or should I say substitution. And this Landen substitution here involves us recognizing that, notice for arctangent function, notice that arctangent, or rather say, let's say if you have tan of, let's say, x plus 1, then this is going to be tan of 1, the tangent of 1 plus the tangent of x, all divided by 1 minus the tangent of, tangent of 1, then tangent of x. So now, by so doing now, then arctangent of 1 minus x over 1 plus x actually is equals to the arctangent, so arctan of 1 minus the arctan of x. So this is a very useful identity. And if we try to connect the dots here, we see that if we can take t to be everything within this, you will have arctan of 1 minus arctan of x, but again, we will have an expression for arctan t. So we're going to take our x to be 1 minus t and 1 plus t. So we're going to make this substitution. This may look like a backward step because it does look like everything is much more complicated now, but it's the right way to go. So for this now, let's find dx. Dx here is going to be just, we'll take derivative of here, we'll get negative 1. So we have negative of 1 plus t minus derivative of 1 plus t is this is going to be just 1 all divided by 1 plus t all to the second power, then dt. Okay, so if we simplify this well enough, you would end up, okay, I have to multiply by 1 plus t, or 1 minus t also. So I would have, this is equals to negative 1 minus t, then then you have minus 1, then you have plus t here, all divided by 1 plus t squared dt. So the t's cancel out, so you have negative 2 all divided by 1 plus t squared dt. So we have an expression for dx. So we could come back. Our integral here is the integral from 0 to 1 of arctan of x all divided by what? 1 plus x. So this would be, and also when x is 0, because t would be 1 minus x over 1 plus x. So when x is 0, t is 1, and when x is 1, t is 0. So it will be the integral from 1 to 0 instead. So let's take this out. Nope. Let me take this out. Or let me just take out the full integral. Okay, let's keep it like this way. It will be the integral from 1 to 0, or 0 to 1. I didn't have to take it out. This will be equals to the integral from 1 to 0 of arctan of 1 minus t all divided by 1 plus t. And you divide by 1 plus x. So because x is 1 minus t all divided by 1 plus t, 1 plus x will just be 1 plus t plus 1 minus t all divided by 1 plus t, and that will be 2. So you have 2 over 1 plus t, then you have dt negative 2, the negative 2 over 1 plus t all squared dt. So okay, now the 2's cancel out. Because of the negative, this would become the integral from 0 to 1 of, this is arctan of 1 minus arctan of t all divided by 1 plus t dt. So you would have the integral from 0 to 1. Arctan of 1 is pi over 4, so you have pi over 4 times, let's say you have pi over 4 times integral from 0 to 1 of dt over 1 plus t minus the integral from 0 to 1 of arctan of t all divided by 1 plus t dt. Now notice that this expression here is basically your original integral. So you see that if you like, we have the integral from 0 to 1 of arctan of x all divided by 1 plus x dx. This is equals to pi over 4 times the integral from 0 to 1 of dt over 1 plus t, then minus the integral from 0 to 1 of arctan of x all divided by 1 plus x dx. Notice that this and this are the same thing, so we can bring it both sides. So you have twice the integral. You have twice the integral from 0 to 1 of what? Arctan of x all divided by 1 plus x dx. This would be pi over 4 times the integral from 0 to 1 of dt over 1 plus t. And this part alone is just pi over 4 times. If you take u to be 1 plus t, this is just logarithm of 1 plus t. If you take u to be 1 plus t, you will, when t is 0, so this will be the integral from 1 to 2 of du over u. I believe so. Yeah. So that would be pi over 4 times logarithm of 2 minus logarithm of 1. That is logarithm of 2. So basically, 2I is pi over 4 log 2. Basically, I, which is the integral from 0 to 1 of arctan of x all divided by 1 plus x, is basically pi over 8 times log 2. And that proves, and that solves the problem that occupied our time here. And this transformation is extremely useful for evaluating this kind of integral, especially featuring the arctangent function. So thank you for watching, and please do subscribe to the channel. Bye.